Hello friends, welcome to this YouTube channel. Today we are going to solve a couple of simple numerical problems on AC series parallel circuits. By solving these problems, we shall learn how to determine equivalent impedance of a series parallel circuit. We shall also learn how to find currents flowing through different branches of a series parallel circuit, phase angle between applied voltage and supply current, overall power factor, consumed power in the circuit, etc. Problem number 1. In the arrangement shown, we have to determine the impedance between terminals A, B and the phase angle between voltage and current. Let us first jot down the given data. Let Z1 be 8 plus J 10 ohm, that is equal to 12.8062 ohm at an angle 51.3402 degree. Z2 equals to 7 plus J 9 ohm, that is equal to 11.4018 ohm at an angle 52.125 degree. Z3 equals to 5 minus J2 ohm. Let us first determine Z1 plus Z2, that is equal to 15 plus J19 ohm. In polar form, this may be written as 24.2074 ohm at an angle 51.7098 degree. Let us mark the middle node as C. Now we shall determine equivalent impedance between terminals A and C. ZAC equals to Z1 in parallel with Z2, that is equal to Z1 Z2 divided by Z1 plus Z2. Using values we get 12.8062 at an angle 51.3402 degree into 11.4018 at an angle 52.125 degree divided by 24.2074 at an angle 51.7098 degree. That gives us 6.0318 ohm at an angle 51.7554 degree. In Cartesian form, this may be written as 3.7338 plus J 4.7372 ohm. Now we shall determine equivalent impedance between terminals A and B. ZAB equals to ZAC plus Z3. Using values we get 8.7338 plus J 2.7372 ohm. That is equal to 9.1527 ohm at an angle 17.4012 degree. Therefore, this series parallel circuit can be replaced by a simple series RL circuit where value of resistance is 8.7338 ohm and value of inductive reactance is 2.7372 ohm. Phase angle between voltage and current phi equals to 17.4012 degree lagging. That implies that the circuit current lags the supply voltage by an angle of 17.4012 degree. Problem number 2. A capacitor of 50 microfarad shunted by a non-inductive resistor of 100 ohm is connected in series with a resistor of 50 ohm to a 200 volt 50 Hz power supply. We have to determine the current in the capacitor, the current in the shunted resistor and the total current. Let us first designate the circuit nodes as A, B and C. Now we shall jot down the given data. Supply voltage V equals to 200 volts. Supply frequency F equals to 50 Hz. Capacitance of the capacitor C equals to 50 microfarad. Resistance of the shunting resistor RSH equals to 100 ohm. Resistance of the series resistor RSC equals to 50 ohm. Let us first determine capacitive reactance. Xc equals to 1 upon 2 pi Fc. Using values we get 1 upon 2 pi into 50 into 50 into 10 to the power minus 6. That gives us 63.662 ohm. Now we shall determine equivalent impedance between terminals A and B. ZAB equals to minus JXC parallel with RSH, that is equal to RSH into minus JXC divided by RSH minus JXC. Using values we get 100 into 63.662 at an angle minus 90 degree divided by 100 minus J 63.662, that is equal to 6366.2 at an angle minus 90 degree divided by 118.5447 at an angle minus 32.4816 degree. That gives us 53.7029 ohm at an angle minus 57.5184 degree. This may be written as 28.84 minus J 45.3018 ohm. Now we shall determine equivalent impedance between terminals A and C. ZAC equals to ZAB plus RAC. Using values we get 78.84 minus J 45.3018 ohm. This may be written as 90.9286 ohm at an angle minus 29.8819 degree. This series parallel circuit can be replaced by a simple series RC circuit where value of resistance is 78.84 ohm and value of capacitive reactance is 45.3018 ohm. By taking supply voltage as reference, we can write V equals to 200 volt at an angle 0 degree. We have determined equivalent impedance between terminals A and C. ZAC equals to 90.9286 ohm at an angle minus 29.8819 degree. Equivalent impedance between terminals A and B, ZAB equals to 53.7029 ohm at an angle minus 57.5184 degree. Applying Ohm's law for AC circuits, we get total current I equals to V by ZAC. Using values, we get 200 at an angle 0 degree divided by 90.9286 at an angle minus 29.8819 degree. That gives us 2.1995 ampere at an angle 29.8819 degree. Now we shall determine voltage drop across terminals A and B. VAB equals to I times ZAB. Using values we get 2.1995 at an angle 29.8819 degree into 53.7029 at an angle minus 57.5184 degree. That gives us 118.1211 volt at an angle minus 27.6365 degree. We have determined capacitive reactance Xc equals to 63.662 ohm. Now we shall determine current flowing through the capacitor. Ic equals to VAB divided by minus JXc. Using values we get 118.1211 at an angle minus 27.6365 degree divided by 63.662 at an angle minus 90 degree. That gives us 1.8554 ampere at an angle 62.6365 degree. Current flowing through the shunting resistor IR equals to VAB divided by RSH. Using values we get 118.1211 at an angle minus 27.6365 degree divided by 100 at an angle 0 degree. That gives us 1.1812 ampere at an angle minus 27.6365 degree. If we observe the currents, we find that the total current and current flowing through the capacitor are leading the supply voltage, whereas current flowing through the shunting resistor lags the supply voltage. Let us draw the Phasor diagram taking supply voltage as reference. Current flowing through the capacitor IC leads the supply voltage by an angle 62.6365 degree, whereas current flowing through the resistor IR lags the supply voltage by an angle 27.6365 degree. Taking Phasor sum of IC and IR, we obtain total current I. Problem number 3. We have to determine the currents I, IL and IC, the overall power factor, the total power consumed in the circuit. Let us first jot down the given data. Supply voltage V equals to 200 volts. Supply frequency F equals to 50 Hz. Series resistor RAC equals to 10 ohm. Series inductor LAC equals to 0.1 Henry. Shunting inductor LSH equals to 0.15 Henry. Capacitance C equals to 120 microfarad. Let us first determine series inductive reactance. XLAC equals to 2 pi F LAC. Using values we get 2 pi into 50 into 0.1. That gives us 31.4159 ohm. Shunting inductive reactance XLSH equals to 2 pi F LSH. Using values we get 2 pi into 50 into 0.15. That gives us 47.1239 ohm. Now we shall calculate capacitive reactance. Xc equals to 1 upon 2 pi Fc. That is equal to 1 upon 2 pi into 50 into 120 into 10 to the power minus 6. That gives us 26.5258 ohm. Now we shall determine impedance of the series branch AB. ZAB equals to RAC plus J XLAC. Using values we get 10 plus J 31.4259 ohm. Now we shall determine equivalent impedance between terminals B and C. ZBC equals to JXLSH into minus JXC divided by JXLSH minus JXC. Using values, we get J 47.1239 into minus J 26.5258 divided by J 47.1239 minus J 26.5258. That gives us minus J 60.6853 ohm. Now we shall determine equivalent impedance between terminals A and C. ZAC equals to ZAB plus ZBC. Using values, we get 10 minus J 29.2694 ohm. In polar form, this may be written as 30.9305 ohm at an angle minus 71.1371 degree. Taking supply voltage as reference, we can write V equals to 200 volt at an angle 0 degree. We have already determined shunting inductive reactance XLSH equals to 47.1239 ohm, capacitive reactance XC equals to 26.5258 ohm. We have also calculated equivalent impedance between terminals B and C. ZBC equals to minus J 60.6853 ohm. Equivalent impedance between terminals A and C. ZAC equals to 30.9305 ohm at an angle minus 71.1371 degree. Now we shall apply Ohm's law for AC circuits to get total current. I equals to V by ZAC. Using values, we get 200 at an angle 0 degree divided by 30.9305 at an angle minus 71.1371 degree. That gives us 6.4661 ampere at an angle 71.1371 degree. Now we shall determine voltage drop across terminals B and C. VBC equals to I times ZBC. Using values, we get 6.4661 at an angle 71.1371 degree into 60.6853 at an angle minus 90 degree. That gives us 392.3977 volt at an angle minus 18.8629 degree. Now we shall calculate current flowing through the shunting inductor. IL equals to VBC divided by JXLSH. That is equal to 392.3977 at an angle minus 18.8629 degree divided by 47.1239 at an angle 90 degree. That gives us 8.3269 ampere at an angle minus 108.8629 degree. Now we shall determine current flowing through the capacitor. IC equals to VBC divided by minus JXC. Using values, we get 392.3977 at an angle minus 18.8629 degree divided by 26.5258 at an angle minus 90 degree. That gives us 14.793 ampere at an angle 71.1371 degree. Taking supply voltage as reference, we can write V equals to 200 volt at an angle 0 degree. We have determined voltage drop between terminals B and C. VBC equals to 392.3977 volt at an angle minus 18.8629 degree. Now we shall draw the phasor diagram taking supply voltage as reference. VBC lags supply voltage by an angle 18.8629 degree. Current flowing through the shunting inductor IL equals to 8.3269 ampere at an angle minus 108.8629 degree. That means IL lags supply voltage by an angle 108.8629 degree, whereas it lags VBC by an angle 90 degree. Current flowing through the capacitor IC equals to 14.793 ampere at an angle 71.1371 degree. It means IC leads supply voltage by an angle 71.1371 degree, whereas it leads VBC by an angle 90 degree. Here IC and IL oppose each other. Since IC is greater than IL, if we subtract IL from IC, we shall get the total current. We have determined total current I equals to 6.4661 ampere at an angle 71.1371 degree. Now we shall determine overall power factor. Cos phi equals to cos of 71.1371 degree. That gives us 0.3233 leading. Now we shall calculate total power consumed by the circuit. P equals to VI cos phi. Using values we get 200 into 6.4661 into 0.3233. That gives us 418.1053 watt. We have determined equivalent impedance between terminals A and C. ZAC equals to 10 minus J 29.2694 ohm. Therefore, we can replace this series parallel circuit by a simple series RC circuit where value of resistance is 10 ohm and value of capacitive reactance is 29.2694 ohm. So today we have solved a couple of simple numerical problems on AC series parallel circuits. By solving these problems, we have learnt how to determine equivalent impedance of a series parallel circuit. We have also learnt how to determine currents flowing through different branches, phase angle between applied voltage and supply current, overall power factor, consumed power in the circuit, etc. Hope this lecture has been useful for you. If you have any question or suggestion, please drop it in the comment section below. If you have liked this video, give it a thumbs up and share it with your friends. Thank you.